We talk a lot about biomass. I remind you that when you go into biomass, most of you think transportation fuel. We can co-fire, okay, biomass in our existing coal plants if we choose to do that. Okay, we just have to say we're going to do it. We already decided we were going to put 10% ethanol in gasoline. Just did it. And here we are arguing about an RPS. Well, it's the same thing. 10% ethanol in gasoline. Why don't we just do it? It sets the market. Okay? We can do the same thing with an RPS. I prefer to think of biomass as baby coal, because that's what it is. It's baby coal. And what do you do with coal? Well, hopefully you use it wisely. Okay? With biomass, sometimes we get into problems with the fact that we're interested in subsidizing agriculture, which is a good thing, but not necessarily good energy policy. Okay? So there's lots of things we can do with it. And perhaps more importantly, I remind everybody that in addition to burning fossil fuels, those are our chemical feedstocks. And it's much better to use them to make something of value, of interest, than to burn them. The lowest value anything has is its energy value. If you can take garbage and make something useful out of garbage, it's still better than burning the garbage. If it really is waste, then let's get the energy value out of it. Okay? So that's where the future sort of lies. Now, I've got two maps here. One's the world's biggest market for solar energy, and the other one happens to be the country I live in, and then the state I live in. Okay? Germany is the world's largest market for solar energy, yet it has half the solar resource of Florida. Okay? Now, New Jersey has far more solar rooftops than we do in Florida, and yet its solar resource isn't the same level as Florida's. Okay? A lot of the case, that's policy that we've talked about here today. It's also the fact that people in New Jersey already pay more for electricity than we do. All right? So you've got a lot of issues associated with this. The other thing that I want to point out here is that quite often people will say, well, geez, the best solar resource is in the Arizona and New Mexico sort of desert area, and that's correct. If that's sort of 100, that dark scale there, then we in Florida are at sort of 75, 85 kind of level. The real key there, though, is free real estate. To collect the sun's rays, you need area. Okay? And where's the free real estate? Well, out in those Arizona and New Mexico deserts, the real estate's free. I can build a large power plant, which is what utilities like to do, and generate energy from that, and hopefully generate it in a cost-effective, competitive way. Where's the free real estate in Florida? That's the key. It's not the solar resource, it's the free real estate. Now, the free real estate happens to be on your rooftops, on top of the Walmarts, highway right-of-ways, underneath those long transmission lines that we run. Okay? Now, the unfortunate thing with that, though, is that's a distributed generation model. All right? In other words, that how does the utility make money when the power plant's on your roof? It's just a new model. It's a different way of thinking of things. We're traditionally used to thinking in large-scale power plants. Eventually, we will end up with situations where we're taking advantage of all the free real estate. Until then, we've got these policy issues to deal with. We've got economics and so on and so forth. Okay? But if there's a will, there's a way. So Germany doesn't have free real estate. Germany clearly doesn't have the sun, and they chose to go ahead and do it. Okay? Now, recently, Tommy mentioned that there's a possibility that some of the bills, in addition to having an RPS, might have what they call tranches on them. And as he pointed out, 300 megawatts for next year, and then maybe 200 megawatts each for the following years. And this last year, FPL put 110 megawatts of solar. So on an installed capacity, Florida went from last to number 2 behind California in these 3 installations. Okay? Now, it's still a very small fraction of the amount of electricity we have, but it can be done. Okay? What I've done here is taken the costs associated with the installations that FPL has installed. Okay? And so you'll see here that in the case of the DeSoto FPL, that was photovoltaics, and that was 25 megawatts. Okay? It turns out that that 25 megawatts generated $2 million worth of tax revenues for the local community, because the property value that FPL put the solar on was now more valuable, so they got $2 more million worth of taxes. Okay? FPL put in 3 solar projects, a total of 110 megawatts. Their target was to charge their utility customers about 31 cents a month more to help pay for that. When you build any new power plant, it costs you more money. You go buy a new car, your expenses go up, folks. Okay, so unfortunately, you don't get something for nothing. Okay, you do have to make an investment in this. So we are paying a little bit more for those power plants, as we would for any new power plant that FPL might have installed in this case. Okay, now 5,000 total jobs came out of that 110 megawatts. Right? If I extrapolate, and my numbers now in green are based on using the numbers in black and making calculations. Okay? So for FPL's 3 projects, based on the tax revenues that it might have gotten from the 25 megawatts, there would be $9 million worth of tax revenues associated with the 110 megawatts. I realize I'm just doing calculations here. Okay? Now, you'll notice I have a 20% solar line there. So magically, if we decided to go ahead and have 20% of all electricity coming from solar, based on using the FPL numbers there, you'll see that I have 27,000 megawatts of power. Substantially, 1,000 times more than the DeSoto plant. Okay? Your average cost per month for customer, and this would be spread throughout the whole United States, would be $38. You say, well, that's a lot of money. Okay? I don't know, $38 a month to generate 1.2 million jobs? Maybe that's not too bad. 1.2 million jobs. There's 18 million people who live in Florida. That's a substantial amount of jobs. Okay? Now you can look at some smaller numbers. 10% solar if you'd like. Okay, it's 620,000 jobs. Okay, or if we go with the tranche, which as you see here, there's a 300 megawatts I put down there. If we added that in, the cost per month would go up to 42 cents on the citizen's electric bill to pay for that. Okay, now remind you, because they overcharged you for the price of fossil fuels last year, you're all getting a rebate in your January electric bill. You may not have got it yet, but you are. Okay, that turns out to be $4 a month. Okay, because they overcharged you for the price of fossil fuels last year. You're getting $4 a month back. Okay, wait a minute. 42 cents is what we're asking for on this tranche, and it generates 13,000 jobs. Okay? And RPS is all about jobs, 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 jobs. We have to do a better job of selling that. Okay? Now, I show you a picture here of how energy generation in the Florida brings tourists to Florida. You may have heard that the Orlando Utility Commission, in concert with the Orange County, put on top of the Orange County Convention Center 1 megawatt of PV. They pay a little bit more for it. They use some tourist dollars. Why did they do it? Because it attracts conventions to Florida. We generate energy renewably. The Super Bowl was all offset. Okay, it was all renewable energy generated. Okay, why do you do that? Because you can make money doing that. That's why Orlando did it. Okay, there's an example of energy bringing tourists to Florida versus energy washing up on our shores and scaring the tourists away. Some of this is just marketing. Now, we brought up the fact that the utilities themselves could go ahead and build these large solar power plants. There's tremendous opportunities for you, the homeowner, to take advantage of putting solar on your rooftops. So as an example, if, say, we were going to get to 20% solar, and I've just speculated here that we might have, and maybe in that scenario, we might have 2% solar PV on your roofs and 2% solar thermal on your roofs. Okay, and I've given you the jobs here, substantial amount of jobs. Okay, in the lower left there, 31,000 jobs. Okay, if we have 2% goal of solar PV on your rooftops, and the solar thermal would be 32,000 jobs, years on top of that. So substantial jobs. I want to point this out. There is a way to get something for nothing. Your goal should be to lower your electric bills. Okay? This is a plot of the per capita electricity use per person as a function of time. Okay? Back in the 60s, the United States, Florida, and California were all consuming around 4,000 kilowatt hours per person in the United States. Then we moved up into the 70s, and everybody's increase was going up. We were getting bigger houses and so on and so forth. Okay? In the Arab oil embargo, after that period of time, California went flat. And the rest of us, albeit not still increasing at the same rate we did before, and if you look way out to the year 2000, and I don't have any data after 2002 yet, but we'll start getting that soon, it looks like we're actually dropping back down. Several states are, as well as California's even dipping down a little bit lower into the future here. But you see that there is a gap. To give you a flavor, that gap between California and Florida is 5,000 kilowatt hours per person. At 12 cents, that's $600 per person. At 18 million people in the state of Florida, that's $10 billion. Because our houses aren't very energy efficient. Okay? So California stopped spending money on electricity because they choose to invest in their own homes. And with that energy savings that they're now not spending on electricity like we are, they used it to purchase solar. Okay? Now, let's talk about the cost of electricity. If you look at this, this is a table then of the 4 largest states plus the United States, and you can see the electricity price in cents per kilowatt hours. Now, I told you that in Florida maybe we're not doing things because it's pretty cheap, and you can see here that Florida and Texas have cheaper electricity costs, 12 cents a kilowatt hour. California's at 14, and New York's up there at 19. And the United States on average is about 12. Now, the interesting thing is, I told you that California's homes don't use much electricity. You can see here that the average home in California, and these are homes, not apartments and so forth. So these are homes. Okay, in California, it uses 689 kilowatt hours per month. You can see in Florida that we use almost 3 times as much as that. Right? So it's not the price of electricity. It's not the price of a gallon of gasoline that matters. It's how much did you spend on this stuff? How much gasoline did you buy this year? Most of you don't even know, but you all know the price of a gallon of gasoline. Okay?